Coming up on This Week in Radio Tech, you want to move in together, do you? I mean, okay, your AM transmitters. It's been lonely for so long, and it's possible to move AM transmitters together if the right conditions are met. You could sell your old property, make a lot of money, and operate efficiently with 2 or more transmitters on the same site. Mike Patton is here to tell us about it next on TWiRT.
This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support. Online at bgs.cc. By Broadcast Bionics with the Bionic Studio, including talk show control, social media, and visual radio. Broadcast Bionics brings exceptional audience engagement to radio and TV. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts.
Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to that light bulb at the top of the tower, right there. And today we are talking about towers and the things that feed towers. That's coming up. The show is called Let's Move In Together with Mike Patton. I'm Kirk Harnack, your host, and I'm in the Telos Alliance studio in Nashville, Tennessee. So grateful for my employer, the Telos Alliance, to afford me a couple hours on Thursdays to put the show together and to bring it to you. If you need anything the Telos Alliance makes, well, you need to check it out. They make a lot of cool stuff. I've got a lot of it right here in my office and at all my radio stations, too. Yes, I eat my own dog food. Hey, let's bring in our guest real quick, and then I've got a quick announcement from Nautel. Mike Patton from Baton Rouge, Louisiana. Come on in, Mike. How are you?
I'm doing all right, Kirk. How are you today?
I'm good. It's good to see you. You look like you're in your office today.
I am. I'm in my little man cave here. I finally moved up in the world about 6 months ago, and I put a bench in my own office. So you see some of the test gear behind me and some of my reference library and various other things. And I occasionally actually get to do a little R&D on my bench here. But yeah, I'm happy here.
See, if I had a workbench in my office, and I do have a messy one in the next room, but if I had a workbench in my office, what would lead up to me fixing something would be, oh, never mind, I'll just fix it myself. Then it would be right there, and I could just fix it myself. Does that happen in your office?
Every now and then, my bench is the one that's used the least because I'm not hands-on day in and day out. But every now and then, one of the other guys will have something they just can't fix. And so, well, we got to go to the old man, and then, and I do the R&D here. This is when I tinker around and try to not blow stuff up and come up with something that's cool. So that's fun.
Well, a few weeks ago we talked with your guy Jordan Tuck, and most of the components that he replaces are older than he is.
Yes, they are indeed, and so that's a source of some amusement to us.
He picks up information pretty quickly, but he does have to pick it up because he's younger than most of it.
He is. He's about, I think, 26 or 27, something like that.
He looks so young.
He does. He has a baby face. He's going to get carded until he's 40.
I bet he will. Hey,
but he has a real passion for audio. He really does. A passion for audio.
Mike, we're going to talk about the idea of putting 2 or even 3 or even 4 AM stations together on the same site. And there's plenty of economic reasons. We'll go through that. There's maybe, I'm not sure political is the right word, but there's reasons that make sense to combine AM stations, kind of like we've been combining FM stations for some years now. AM involves, I think, a lot more a lot more space, that's for sure, and a lot more thought has to go into it, I would think, and you're going to tell us about that from soup to nuts. We got a whole list of questions laid out here, and I think it's just going to be a fascinating discussion. This Week in Radio Tech is brought to you in part by our friends at Nautel. There's a couple things I want you to know about Nautel. First of all, they got a couple promotions going on that you ought to ask your Nautel rep about. They have a free second backup exciter promotion. You get a free second integrated redundant exciter on any GV series transmitter. Contact your Nautel rep about that or go to nautel.com/11things. That's 11 things. Nautel.com/11things, or hey, talk to your Nautel rep. The other promotion is what they're calling the 4610 VS savings promotion. So you got 3 offers here. The 4 is $4,000 off the purchase of a VS 2.5 transmitter. I own one of those. It's a great transmitter. You get $6,000 off the purchase of a VS HD digital exciter. So that's a combination of $10,000 off those 2 items if you buy those. $10,000 off You can get more information on that by calling your Nautel rep or going to nautel.com/4-6-10. That seems like a lot of hyphens. I'd call my Nautel rep. And finally, Nautel's been running their Transmission Talk Tuesday roundtable discussions for over a year now. That's all through COVID. It started as a way to stay in touch with the radio community through that pandemic lockdown. But there's popular today is when they began with over 5,300 registrations to date and over 100 attendees per session. These are really successful, and you ought to be part of them. Don't miss out on the opportunities to learn from and discuss engineering topics with your peers. And by the way, it's a round table. That means you get to participate. If you want to ask a question of the expert, you certainly can. There are 2 sessions left in June. June 22nd coming up next Tuesday. STLs, all about STLs, moving signals from here to there. And June 29th. Tips and thoughts for contract engineering. You know, a lot of folks have become contract engineers, competing with Mike Patton when they need to. So check that out from nautel.com. The Transmission Talk Tuesday. Registering for that is really easy. Go to nautel.com/webinars, nautel.com/webinars, and click to register. It's really easy to do. Just takes a couple minutes. All right. Thanks, Nautel. All right, Mike Patton, let's jump right into it. I've got a list of questions here. Again, the topic is putting AM transmitters together on the same piece of property, oftentimes into the same tower, not always. And this is pretty interesting. First question, Mike, what promotes this line of thought about putting AM stations together on the same piece of property?
Well, to bottom line it, the property is often worth more than the radio station. A lot of times, AM stations in particular are built on legacy sites that were sited and constructed 40, 50, even 60 or more years ago. And at the time, they were often undesirable property or marginally desirable property. But times have changed, technology has changed, floodplains have been drained, and the suburbs have sprung up everywhere. And so there's a lot of sites that were once considered worthless for anything other than. And the joke was they all got the same thing. It was airport cemeteries, AM stations, and golf courses because they all took up a lot of land. And they didn't have to be pristine land as long as it wasn't terrible. But sometimes it was terrible, and those sites tend to still be there. Like there's some out in the bay in some coastal communities or in river flood plains. I can name several of those. But a lot of sites that were marginal 60 years ago are now valuable real estate. Just recently in Washington D.C., one of the big old line DAs up there abandoned their site because it was more valuable as land than as a radio station.
I think we can probably all, if we deal with AMs at all, we can think of a transmitter site that's had subdivisions come up around it. We used to build AM sites out in the country. We still do. And the country keeps moving. People keep, suburbs keep expanding. Yeah. So
right. I worked at a station a couple of years ago down in the the Fort Lauderdale area. Actually, it was a combined site already, 2 stations, and the owner decided that they got an offer from the city to buy the piece of property and make a park out of it, because it, like you said, it was now surrounded by these upscale subdivisions. When it was built years ago, it was way out in the country, and then when they diplexed into it, it was still sort of way out in the country, and they decided to just sign one station off and diplex the other one in another site they have.
Wow.
So, it's a park. In 3 months, it went from a working transmitter site to a park.
So this is essentially giving your AM transmitter a roommate, right?
Yes, that's essentially it.
And the benefit of being a roommate is you can share the rent. Yes, you have to share the bathroom. Yes, you have to share the front door and the living room. But your rent's cut in half, and somebody else gets to live where one of them would have lived. So let's talk about, if even thinking about this, what technical parameters need to be true to even think about getting 2 AM stations together on the same site?
Well, the first one is the height of the tower. That the lower the frequency, the taller the tower has to be in order to radiate properly. The FCC has minimum efficiency standards. Basically, the lowest they'll approve is about a 45-degree tall electrical tower, and that's maybe at 600 kilohertz, it might be as tall as 275 feet, 250 feet, something like that. So if you've got a low end of the band station and your tower is 100 feet or 150 feet or 200 feet tall, that's a constraint. You're just not going to get that past the commission.
Yeah.
But that's sort of an extreme case. More often, a matter of compromise is directional pattern. Um, if you're trying to take a station that has a directional pattern using several towers at site A, and then find a way to make an acceptable directional pattern at site B with a tower arrangement that made sense for the station that was originally built, site B was built out as, then you often end up having to make a lot of compromises. But on the other side of the ledger, chances are that the directional pattern that was designed to put the signal where the people were from a station built in the 60s doesn't work anymore anyway because the people built somewhere else. A lot of times, in a lot of older communities, and I could name a dozen off the top of my head, where the population in the 50s or the 60s, when these AM directionals were designed, um, those neighborhoods are now older and possibly less desirable. And a lot of the newer neighborhoods are way out of the country in land that the original directional doesn't cover worth a damn anymore anyway.
Okay.
So
Okay.
having to choose a set of compromises from a set of towers at a different site isn't automatically a bad thing. And modern computer DA design software can produce a remarkable pattern from an almost random set of towers in a field. So it's not nearly as bad as it would have been if we were doing this in the 60s or the 70s with the relatively primitive techniques for calculating DAs we had at the time.
Gotcha. So, what about tower height? Obviously important. If you have short towers because you're at the high end of the dial, you're not going to be able to invite a station that is at the low end of the dial to share your short towers. That's not likely to work at all in terms of minimum efficiency. But what about the other way around? Can I, if I'm a 1500 and I've got an opportunity to co-locate with a 600 kilohertz, can that work?
It can, but you have to take some special considerations. It's possible for a tower to be too tall. The highest, the FCC will approve any AM tower is about 210 degrees electrical, a little bit more than half wave. Theoretically, the most efficient ground wave comes at 5/8 wave, 225 degrees. And if you go above that, very, very quickly, a tower will generate a second lobe at a high angle of radiation, and the ground field will suck in a lot. Yeah.
So you'll put power this way, which will bounce and interfere with other people, and the ground field will come in.
Right.
Okay.
And birds don't fill out books, and at night, in particular, neither do the alligators. And at night, in particular, that skywave, that'll generate skywave. And again, the FCC won't pass it. So there are techniques for doing this, but they're really tricky. You can do things like have skirt wires on the tower that detune the upper section of it, so that it basically disappears electrically. And I've worked on several arrays that do that. But then the problem is, how do you make it disappear for the high end of the band station and not make it disappear for the low end of the band station?
I bet ham operators have ways to do that. I bet that's possible.
But what works for a ham operator at 500 watts is a little bit trickier for someone doing 50 kilowatts.
And trying to be more wideband than a ham operator is with the bandwidth.
And also being reliable for 20 or 30 years.
Yeah.
If you have a box full of tuning components at 1,000 feet in the air, like a station in Memphis, Tennessee, WMC, just off the top of my head, if you've got a burnout up there, you're going to drop some bucks just to go up there and see what's wrong with it.
You're right.
You can't open the door of the box. So
that's true. Okay. So it's possible to have tuning components up in the air on the tower. I've seen towers that have that, but you're right. That whole ongoing expense will come up with that arrangement.
Right. And one of the things we have to live in the real world about with AM stations these days is that most of the budget is gone.
Yeah.
That's something we wouldn't blink an eye at 20 or 30 years ago. Oh, $1,000 for a tower climber? Get his ass out here. But these days it's like, oh, maybe not. So
we've talked about tower height, co-locating. Let's talk about separation on the AM dial. How close can two stations be and work on the same piece of property? And then, of course, how far apart they are, there's not a problem except for the tower height. The tower height becomes the problem there because they're different for different frequencies. But how close can stations be together?
Anything less than about 120 kilohertz apart, and the filters have to be more complicated. And anything less than about 50 or 60 kilohertz apart is basically a no-go. But the closest any two stations to in the same town could be to each other and meet the third adjacent rules is 40 kilohertz. So I would not want to try to do a 40 or a 50, especially at high power. You can do anything wider than that, and anything about more than 120 kilohertz apart generally only needs a single stage filter. And it's certainly more than 200 kilohertz apart. That's relatively easy from a filter standpoint, design standpoint.
So 100 kilohertz would be like if you had a station on, let's say, 1410 and another one on 1510. That's 100 kilohertz apart. Those could live together pretty well.
Those could live together pretty well, but the filters would require two-stage filters, which would be considerably more expensive than single-stage filters, and you have to worry about bandwidth because trying to get rid of somebody who's not very far over here and still have a fair amount of bandwidth over here, that's a trick.
So if you had an 800 and a 970, those could easily. That's 170 apart. Yeah.
Yes, that's right. We just did one in here in town. That's a 1260 and a 1460. Okay. And we did two-stage filters with that out of an abundance of caution, and it tuned up just great, and the bandwidth for each station was fine, and the Smith chart rotation was good, and that was a great job.
I want to hear more about that in a few minutes. We're going to take a break in a minute, but first, I want to take a look at a picture. In the background here, I sent a picture over to Suncast of this two-station site in Miami, and I think it's particularly interesting because I was going to ask you about directionals. Suncast, if you want to go ahead and throw that Google Earth picture up, the wide shot. Kind of give us a tease for what we're going to be talking about. What are we looking at here, Mike?
Well, the diplexing filters are all at each tower. That the transmitter building itself has two separate facilities in it. Each station has a main and an aux at this particular station, as I understand it. And there's two separate sets of coaxes that run from the building to each tower. But in each tower, there are basically parallel tuning units, one for each station, and then filters between the tuning units and the tower that pass the one station and reject the other for each of the stations, and then they come together and then feed the antenna.
On this picture, sometimes Google Earth will paint you a tower there. These pictures were taken from directly overhead, not from an angle. This angle is a false angle view, but so you can't see the towers, but you can see where they would go. They're at the middle of each, three-legged design there, and there's a little tuning house at each one. I'm counting 7 towers on this property, plus the transmitter building at the end of the road there. Is that right?
Yes, that's right. This is a site I was just at a couple of months ago, and I believe this is the one in Orlando, not Miami. You said Miami?
I'm sorry. I keep saying yes. I'm so sorry. I keep saying Miami. This is Orlando. Thank you.
Yes, and so yes, all the transmitters are there in the building in the middle, and there's 2 sets of coaxes and 2 sets of sample systems. Interestingly enough,
of course, yeah.
Right, and 2 sets of sample coaxes, 2 sets of sample toroids, 2 antenna monitors, and the antenna monitors are specifically built to trap out the other frequency so that they're not bothered by the current for the other frequency flowing through the tower.
Wow. Okay, so we're going to find out some more interesting things about this particular site. And you've got, you told me something earlier today when we were doing a little pre-show about this show. You told me something about the way the switching or the feed is done to the towers that just absolutely blew my mind. And we're going to talk about that as we move through the show. It is This Week in Radio Tech number 549. I'm Kirk Harnack. Michael Patton, the owner of Michael Patton and Associates in Baton Rouge, Louisiana, is my guest. And we're talking about moving in together. Getting AM stations together on the same piece of property. And hey, real quick inside baseball note right here. Mike, we're going to do a 2-minute spot here, and we'll be off camera. I need you to check your microphone feed. I'm not absolutely sure that your headset boom is the mic that's being used. So do that while we're in the commercial. We'll be right back in 2 minutes.
Camera One from Broadcast Bionics. Designed to bring video to your audio content. Visualizing radio and podcasts for social media. Camera One can automatically create, capture and brand professionally switched video for live streaming or upload, making your production shareable. Control and configure using a web browser on any device. Camera 1 is available as a 4-camera or 8-camera system using the Blackmagic A10 Mini range, including the A10 Mini Extreme. You can use cameras to suit your studio and your budget. You'll need one camera for a studio wide shot and usually one camera per microphone. A standard multi-channel sound card or IP driver monitors audio from each studio microphone, and we work natively with Axia systems. Ideally, this will be a post-fader feed from each mic, although you can use pre-fade audio or a mic split if that's all you have available. These audio levels are used to intelligently switch the video feed when each contributor is talking. You can also group microphones together into one shot and use the audio from a mixer's aux bus. You can use Camera 1's auto switch feature, or disable it and switch using the on-screen buttons or the buttons on the A10. Recordings can automatically start when you tell the system you're on the air. This on-air indication can be linked to your studio's red lights via IP or an Avantec Adam GPIO interface. You can quickly browse all the videos that have been automatically created during your broadcast, download them and post. Camera 1 is a user-installable system. You'll need a good spec Windows 10 PC, i7 with plenty of storage and 16 gig of RAM. It's better if this machine isn't used for anything else. Remember, you can control the software in a web browser on another device on your network. Camera 1, a thrifty way of creating scroll-stopping video from your show or podcast from Broadcast Bionics.
You know, not only is Camera 1 a cool system, but that is some good writing on that copy. A thrifty way to make scroll-stopping video. How about that? Hey, it's by the way, if you want to check out that, go to bionics.radio. Bionic, singular. Bionic.radio is the website for Broadcast Bionics in the UK, and they sell their equipment and help radio stations literally all around the world, and all their stuff is proven in some of the biggest markets in the world, including London. On that commercial, you saw a lot of shots from London radio stations. So check them out at bionic.radio. Hey, I'm Kirk Harnack along with Michael Patton. Michael, I'm sorry if I caused any confusion by saying you were on the wrong mic. Maybe you are on the right mic.
Well, that's all right. I probably needed to move the boom a little closer to my mouth anyway. So
you're just fine. My fault. Hey, so let's move on with the questions. We're talking about moving AM stations together, sharing a room, as it were, and sharing some expenses to make things better, especially if your AM transmitter property has become incredibly valuable. We talked about we talked briefly about directionals. So I can imagine this being kind of easier with 2 non-directional stations or 3 moving onto the same tower and all the transmitters feeding into the same tower and none of the transmitters knowing that the other is there. That's very critical. They think they're the only one. Right there, they all have blinders on. How do you work out a directional AM station when you have more than one on a site? How does that even work?
Well, that's a whole new ballgame. You start, of course, with a consultant who looks at the possibilities for generating a pattern that will attempt to cover the audience that you have, and hopefully look forward to the future and try to decide if there is a point in worrying about whether population is going to shift in the next generation or so. But once you decide what you want to cover, then that person will need to look at what patterns you can generate with the towers that are there, whether perhaps it would be good to maybe put one new tower in just for the new station, or whether you can make a pattern that's acceptable with the towers that are already there. And then there, at each stage of this game, there are compromises that matter. And obviously, one of the biggest ones is cost versus versatility or usefulness. That if you can't make a pattern that will serve you at all with the towers that are there, then you have to put in a new tower, and new towers aren't cheap. But on the other hand, if you can't afford to put a new tower, then you'll have to fall back on, well, what can I do with what's there? But once you have a pattern that will work for the new station, then you can go look at designing a phaser and a tuning network system that will work for that. And that's basically the same for a diplex station or a standalone, that the the design parameters don't change. The equations don't change. The filters make each station look invisible to the other as long as they're
Mm-hmm.
properly tuned. So that's a matter of proper installation and tuning. But from a design standpoint, uh, there's really no difference, except you have to spec the traps themselves, the filters, and those all the capacitors in the filters have to be vacuum capacitors, because mica capacitors are not temperature stable enough to maintain the sharp resonance that's required for some of these parallel resonant networks. That's a lesson I learned the hard way. And so you have other constraints there, but it's fairly straightforward. One of the issues is that, and this goes back to the closer together the stations are, the higher the circulating currents in the
Mm-hmm.
traps. And a circulating current in a resonant circuit, a parallel resonant circuit, is a current that runs around the circle and doesn't actually go in or out. It sounds like a mathematical only construct, but believe me, circulating currents are very real. And you have to think about the heating of the coils, and you also have to think about the voltage on the capacitors. Especially at very, very high power levels, so like 50 kilowatts. Sometimes you'll have vacuum capacitors that might have as much as 70 or 80 kV across them.
Oh my! Wow!
And
Wow!
those are extremely expensive.
And by the way, on the vacuum capacitors, typically in my career of dealing with AMs, typically for me, vacuum capacitors were also vacuum variable capacitors, which get really expensive. Are you typically dealing with fixed vacuum capacitors in this kind of work you're talking about?
It depends. Obviously, when you could use a fixed capacitor as opposed to a variable capacitor, it's cheaper. But
Mm-hmm.
what you're trading there is the initial cost versus the hassle of tuning it. That if you use a fixed capacitor in a circuit that has to be tuned, your only option is to put it in series with an inductor and use
Right.
the inductor to make the capacitor look variable. And sometimes you could use a roller inductor, which is relatively easy to fool with, but a roller inductor is a pretty serious unreliability not asset, but risk.
Mm-hmm.
Because
Mm-hmm.
sooner or later that roller is going to get funky, get dirty, or have a wasp land on it or something like that, and that's a point of failure that you don't want to have. But the other trade-off is trying to move a little slider half an inch here and a quarter of an inch there, over and
Yeah.
over and over and over
Yeah.
until you get the tuning just right. Is a good way to be ready to walk away and open a lemonade stand somewhere.
Yeah. Well, if you're getting paid by the hour, it's not too bad, but there are limitations to getting paid by the hour too.
Well, and even so, you're up there with your hand inside this coil in the back of a tuning unit somewhere, and you're trying to move a strap about that far.
Oh yeah.
Yeah, oops, I overshot it. Got to go back the other way. Oh, I've fought it and fought it and fought it till it's like, somebody go get me a fifth of whiskey.
Well, we're in a minute. We're going to take a look at some examples of these tuning houses, but I want to ask you about switching, because that was a big question for me. I remember taking care of some AM directional sites, and some had simplistic relay, just a couple of relays, 3 or 4 relays, maybe switching networks that would check to make sure the transmitter was off. That they would open the interlock and then do some switching, and control relays that were big, those big seesaw relays that were out at the towers. And then those would report back, and then it would go turn the next transmitter on and all that stuff. And that was simple, but I also dealt with some custom designed ones that were designed, frankly, in a hotel room in Paducah, Kentucky, and then built. And thankfully, nothing ever really went wrong with it. It was a 3 pattern switching arrangement for day, critical hour, and night. This was at WPAD in Paducah, Kentucky. And for the years that I engineered there, I think we had a few ICs pop after lightning storms. It was easy to find the problem because I think the top of the IC had come off. Oh, there's the problem right there. And luckily, they were easy enough to fix. But I got to imagine that that these can get pretty complicated. Some engineers like to use PLCs, programmable logic controllers, to control these. There's different ways to effect a series of switching so that things go right at sun up and sundown. But you told me that when you put 2 AM stations together, or even more, at a common site, the switching may not be the most complicated thing going on there. So tell us about that.
Yeah, the switching really isn't affected by the diplexing operation, that each station switching can be done as though the other station or stations weren't there. You simply design each station with the day-night critical hours as needed switching, and you leave it. Each station switches patterns independently of the others. There's typically no switching involved in the traps. The traps are just in circuit all the time. The only thing there would be if you wanted to have an emergency bypass around a trap. Obviously, in that case, you'd have to favor one station over the others, because if you bypass the traps, only one station is going to work. And even then, it's very difficult to just bypass a trap and have it work, because you have to take into account things like stray capacitance to ground that changes if you take a resonant circuit out of circuit, even though it doesn't have any shunt elements. Just the fact that it's in a box has a certain amount of capacitance to ground, and if you bypass all those components, you change the shunt cap, the parasitic straight capacitance, and that ripples all the way back to the transmitter and can affect the load on the transmitter. So the switching really isn't affected. You just act as though the other station isn't there.
Okay, that's I'm a little hard for me to conceptualize. I totally believe you, but I'd love to go see this in practice. And I know you've got a couple stations right there in Baton Rouge. Hey, I need to go to Honolulu. I think there's a place there where there may be as many as 4 AMs combined into one tower in Honolulu. So that sounds like a good fact finding trip, doesn't it?
It does. And there's another one in Traverse City, Michigan. But if I go Honolulu, Traverse City, Honolulu, Traverse City, I think I know which one I would come down on.
I've asked Suncast to have ready, and we'll do it right now, to look at the schematic diagram that you supplied. And after the next break, we're going to look at how the schematic actually plays out in terms of components and tuning houses and stuff. So Suncast, if we could take a look at that schematic diagram, if you got that handy. All right, that looks good. Mike, walk us through this. What's going on here?
This is a 4-compartment box that we had made, had the box made for us by Kintronics, and then we put all the stuff in it. I have a mouse here, but I don't guess you can see my mouse. But
No,
the lower left compartment is the tuning unit for 1460, and the compartment on the lower right is the secondary trap for 1460. The one on the upper right is the primary trap for 1460. You can see where the antenna is connected at the top with the static drain choke and an arc gap. And then the upper left compartment is the primary trap for 1260. 1260's tuning unit in a separate enclosure was a relatively recent vintage, also built by Kintronics. So we simply left it and put the secondary trap in that box, so we didn't have to build a 6-compartment or 2-3-compartment boxes here, and that worked out well, and it didn't involve having to spend any more money than we had to.
Gotcha. So okay, so the station that's a 1260, its tuning unit, which would be in, like 1460s in the lower left, its tuning unit is external. It exists. It's in good shape. You're going to use it fine.
And there was no need to take it out and bypass it and have to fool with all that stuff. It was perfectly fine.
And why did 1460 need 2 traps? The first one and then the second one, the series filter and the shunt filter.
They're only 200 kilohertz apart.
Okay.
And my calculations indicated that the rejection between the two would be marginal. Both stations are using BEAM5s, and that particular transmitter is very sensitive to any return signal and has a tendency to make spurs very quickly. Some of the other transmitters that are out there, their output networks are much narrower. The SX and the Gate series from Harris and the DX series both are a fairly narrow output network, and so they're not nearly as likely to make a spur from a station that might have a little leakage back into them. But the AM transmitter line from BE has a fairly broad output network, and they will make a spur in a New York minute.
Now, the upper right on the drawing here that says 1460 series filter. Can I think of that as a band pass filter that passes 1460 and then has skirts that reject stuff up and down the dial from
Well,
there?
it's a little more complicated than that.
Hmm.
If you look at the two capacitors in parallel, we're doing that just for value.
Mm-hmm.
They together they're a 300 puff cap, and they're in series with L12 to their left, and the two of those make a series resonant filter read a short at 1460. But at 1260, they have a net capacitance, and so that network is parallel resonant with L13 above it, so that it looks like a high impedance at 1260 and a short at 1460.
Ah, gotcha. Okay. So it is more complicated than just a band pass. It that does two things right there.
Yes, that does two
Yeah.
things right there. And then if you go down to the compartment below that, that
Mm-hmm.
filter does the same two things in reverse. That it is series resonant at 1260, L11 and C7, which looks like a short to ground. So that
Mm-hmm.
takes anything that got past the primary filter up top and takes it to ground. But C6 there resonates that circuit at 1460, which is then net inductive because 1460 is above 1260. So you resonate it with a cap, and it looks like it's out of circuit at 1460 and doesn't affect the bandwidth.
And then, of course, the bottom left box there is simply a T network, right? To
It's a
match the
conventional
impedance.
T network. That's right.
Mm-hmm.
Couldn't be any more standard. And if you've done everything right for tuning wise, the impedance at J5 is essentially the same as the impedance at J3 because L12 and C whatever that is, 6, C9, A and B look like
Mm-hmm.
a short. So J3 and J4 look like they're shorted together at 1460. And the resonant circuit below there in the lower right cabinet looks like it's not there at 1460. So basically, whatever's passed from whatever's J3 is passed on to J5, and it's just a matter of matching it back to 50 ohms. If you look under at the upper right under the tower, you will see where it says measured base Z at 1260 and predicted base Z at 1460. That's because we couldn't shut it off at the time to measure 1460, but the actual measured impedance at 1460 turned to be pretty close to that. So
Wow.
that worked out well. So we
We're
just
going to
matched that
see
down to 50 ohms.
in after the break here, we're going to see how I don't know if it's necessarily this schematic, but we're going to see how this stuff plays out in real life into a real tuning house, and Mike's going to give us a tour of that. Mike Patton is with us on This Week in Radio Tech. He's the owner, proprietor, founder of Michael Patton and Associates in Baton Rouge, Louisiana, and he does this kind of consulting work all over the country. Our show is brought to you in part by my friends at Angry Audio. The website is angryaudio.com, and here is what's taking the studio world by storm. It is this Bluetooth audio gadget. This just amazing device. Of course, Bluetooth isn't all that amazing, but when you do it right, when you really design the circuitry right, you design the audio's inputs and outputs correctly, and you think about how this is going to connect to a cell phone, and you implement Bluetooth to its highest advantage, this is what you get, the Bluetooth audio gadget. It's got a quick little pairing switch right there. It's spring-loaded so you can hear it. There you go. You put it in the pairing mode, you pair your Bluetooth phone with it, and then on the back, it's got audio gazintas and gazoutas in and out, and that means you can use this to talk to callers on the air. You can take your inexpensive audio console. Let's say you've got an inexpensive console like a Behringer or a Mackie or any one of the other brands, and you can get a mix-minus out of it by using the aux bus. You can send mix-minus to the caller through Bluetooth. You're talking on your phone. You don't need an expensive POTS line. You don't need an ISDN line. You don't need an expensive phone hybrid. You can use this, but not only can you use this for putting callers on the air, you can also use the Bluetooth audio gadget to play music or interviews, high quality audio out of your phone. Let's say you've gone out in the field, you've gotten some interviews, or maybe you've downloaded some songs that you want to play, other kind of audio. You put it in that mode, the one-way mode, and you get the highest quality audio possible, and it really does sound good. Angry Audio's Bluetooth audio gadget. Remember, at Angry Audio, you can also get all the Studio Hub stuff to wire up your studio. I was installing some of this stuff just last week at my stations in Mississippi. We had to hook up an audio processor to an Axia X node, and this just made it so quick and easy to do. I didn't have to do any soldering. The Bluetooth, all of the Studio Hub stuff, the cable adapters like these, the little hardware dongles that let you get GPIOs in and out of all kinds of various formats, go from one format to another. They got all that stuff at Angry Audio. Go to angryaudio.com and click on the Bluetooth. I keep wanting to say Bluetooth. What is that? I got that in my mind. Click on the Studio Hub stuff, and you can see the great selection that they have of that. All right. Thanks a lot, Angry Audio, for sponsoring This Week in Radio Tech. The other cool thing that we've got is the Max Connect. I used this again just last week. This will save your bacon. It's a fixed IP address, 4G LTE modem with high priority data. So you can be at a mall, a ball game, someplace where there's a whole bunch of goobers using their phones, updating their Facebook. And you know what? This will get data right through, because the only thing with a higher priority than Max Connect Wireless is first responders. And of course, you want them to have data throughput, but you can be in a crowd of people. And I've seen this happen. My friend Sam Wu at the New Jersey hockey games in Newark gets his signal right through, even when the stadium is full of people. In fact, we got John Takak, a quick video here with John Takak to tell you about why they use Max Connect Wireless.
With all of the recent cybersecurity attacks against large corporations, we were looking for a product that would give us the ultimate security at our transmitter sites and as well as with our broadcast equipment. Max Connect fits the bill very well. Its greatest security feature is the fact that it gives you a single static IP address. Using this single static IP address allows us to close hundreds of open ports on our firewalls across the company and restrict access to only the Max Connect IPs. This has greatly reduced our exposure to the World Wide Web and made us much more secure moving forward. It has also given us the ability to expand as needed in a secure fashion.
Our industry really owes a debt of thanks to Josh Bone and at Bone Broadcast and Max Connect Wireless, because he really put this thing together and worked on it for several years to make sure that we as broadcasters had access to prioritized wireless data and fixed IP addresses, as John just talked about. There's the website, maxconnect.com. Yeah, it's spelled funny, 2 X's and a K, because all the good names are taken up. So maxconnect.com. Check it out. Lots of broadcasters are doing this, and maybe you should too. All right, it's episode 549 of This Week in Radio Tech. I'm Kirk Harnack in the Telos Alliance studio in Nashville, Tennessee. My guest is Mike Patton. Mike, I think Suncast should have some more pictures ready for us of these tuning houses. Anything you want to do to set this discussion up, Mike Patton?
Well, let's see what the next one up is.
Okay. Suncast, your choice. Ooh, that's a big one.
This is a big 4-compartment box that Kentronics built for us, and this is here in our shop before we deployed it. Pardon the mess in the background. But we were fairly proud of this one. It is in service right now in Columbus, Georgia, and it is diplexing, I believe, 1270 and 1430. And it's a two-stage trap in each one. The 2 outside compartments of the 2 tuning units, this is all in one thing. And the 2 inner compartments there are both the primary and the secondary filters. As you can see, it's pretty crowded, but it does the job. And I was just over there a couple of weeks ago rebuilding a transmitter for them, and this little fellow's just chugging right along. As you can see, there's lots of vacuum capacitors there, both fixed and variable in the 2 center compartments. And then the ATUs use mica capacitors in the outer compartments because we can. We don't have to use vacuums.
Let's keep this picture up for a couple of minutes while we talk about it, Suncast. So, Mike, a couple things I noticed, and I always like to do a little bit of basic teaching on this show when we can, so that people know what they're looking at, what the fundamentals are here. First thing I want to point out, and Mike, you can explain this, why are some of these coils at right angles to each other? A couple of them look parallel, but the others are, mounted such that they're at right angles.
All coils should be at right angles to each other, called orthogonal to each other, because coils work by generating magnetic fields. And anytime you align a magnetic field between 2 coils, you have mutual coupling between the 2, and energy is passed. because anytime an electric field, um, anytime current flows through a wire, a magnetic field is generated. And anytime a magnetic field crosses a wire, an electric current is generated. And because AC is nothing but changing currents, sinusoidal, back and forth, the magnetic field in a coil is collapsing and rebuilding at the rate of the frequency of the radio station, 1400, 1.4 million times per second. If it's a 1400 kilohertz station. So in fact, we ended up having to go back. I'm glad you caught that. In the center left compartment on the left wall, you'll see a fairly small coil under a much larger coil above it, mounted near the ceiling. We ended up having to rotate that coil 90 degrees and have it stick out into the box and be supported from one end because we had unacceptable interaction with the other two coils in that compartment.
Ah, okay. All right. The other question that... go ahead.
And in the two ATU compartments, you can't really see it on the one on the left because it's in shadow, but all three coils in each of those are at right angles to each other. And then the center right compartment, there's only two coils there, so it wasn't as crucial. The static drain choke is in the back, as you can see there, but because there's very little current that flows through the static drain choke because it's such a high reactance, you don't really have to worry about the magnetic field from it.
Ah, okay. All right. And the other question I had is, folks may wonder, okay, I see a total of 1, 2, 3, 4, 5, 6 green things with a hole in it. And I know that we call them a J plug. They're standing on those ceramic twin pillars, those little ceramic standoffs along the front bottom of this box. Why do you need all these J plugs?
Well, those are insert points for ammeters or bridges, impedance bridges. And they are convenient places to measure impedances in the box here. The two in the middle, the two in the center, are where the two sides feed the antenna. And the two at 1/4 and 3/4, if you will, are between the ATU compartment and the trap compartment. And then the two at the outer edges are where the coax comes in from the transmitter. That's an important point there because that's the point that needs to be 50 ohms, 50J0, for the transmitter to see a good load. The two in the 1/4 and 3/4 positions are, if you'll look carefully, you'll see that they're in series with the toroidal transformer that feeds the RF ammeter for each station. That's where the FCC licensed antenna impedance measurement is made, not directly feeding the antenna in a diplexer, because at that point there's too much current from the other station for an impedance bridge to read it accurately. So the primary, or in this case, the primary and secondary filters have done their magic between the center pair and the 1/4, 3/4 pair. So at that point, there's essentially no current from the other station, and you can safely make a measurement with the bridge inserted there. And if you turn the station on that side off and turn the station on the other side on, you will notice that the ammeter does not deflect upscale. If you put that same ammeter in the center there, I guarantee you it would deflect upscale if the other station were turned on, even though theoretically there's no current flowing because of the parallel resonant network has done its thing. But stray capacitance to ground, which is absolutely unavoidable, will always suck some current through it. And so you want as much isolation as possible.
Speaking of ground, let's stay on this picture for just another minute. I see a lot of copper colored metal in this thing, especially on the front and bottom, but it goes up either side and then goes toward the back of each of these compartments. A lot of copper here. What's that about?
Well, any shunt component by convention needs to be tied directly to copper. And the J plugs are all in the front there. You'll notice on each side of the J plug, there's a little metal post sticking up on each side of the insulators. Those are places to clip the big ground lead for the bridge, because everything is relative to ground. So the impedance bridge has big claw-like Mueller clips that grab the hot leads, and also two that grab the grounds. And the ammeter toroids need to be sitting on copper for best best grounding. And it's hard to see, but there is a little tiny side strap that runs under each one. But more important than that is any of the shunt components, the vacuum capacitors or the mica capacitors that are shunt elements need to be solidly connected to copper. The coax clamps for where the two coaxes come in near the left and right side, you will see are in the middle of the straps there. And the RF ammeter readout, actual meter boxes on the brackets on either end are also connected to the strap there running up the side. That's mostly to protect the meter. So if a transient comes in, it's got every reason to take it back to ground and not blow up the meter.
Let's Suncast. Let's switch to another picture as soon as you can. Another one of the tuning boxes. What are we looking at here, Mike?
This is a simple primary filter only box that I designed some years back for a station in North Carolina, and I visited it last year because they actually looked at they added a third station to this tower. I bid on that, but did not get that bid. But so this box is still there, but they added another box around the corner for the third station and made some modifications to this. But it's basically the same design. You see the 6 J plugs, and this is not as complicated because it has only primary filters and not any secondary filters. You'll see the toroids are on the outside of the two here, and the meters are on the inside. This is actually done sort of backwards from the other one. And the reason for that is this is kind of an interesting situation. This is a self-support tower. You can't see it because it's behind the camera, but it has 2 sets of skirt wires. There's a total of 6 skirt wires, and 3 of them are tied for one station, and 3 of them are tied to the other station, and they are tapped at different points on the tower to give the best base resistance, base impedance for the 2 stations at the 2 different frequencies. So if you look in the upper left corner, you will see a steel cable going out to that set of skirt wires, and on the upper right corner, there's a different steel wire going out of frame to the other set of skirt wires. And so that was a design innovation we came up with here because these stations were fairly far apart. One of them was like 910 and the other was 1450, I think. And we had to really, take that into consideration. Also, the power level on one of these was very low, and the base impedance ended up to be fairly high. So if you look in the upper left, you will see a toroid, one of the delta ammeter toroids, and there's a loop through it. The center conductor doesn't just pass through it once, it passes through it twice.
Yeah.
And that doubles the sensitivity of the meter. The lowest meter you can buy from Delta is 5 amps. Well, doing it that way, now all of a sudden it's a 2.5 amp full scale meter. So we were able to get a much more sensitive reading for the fairly low power or low current there because the station is at low power and the impedance is very high.
My goodness. Okay.
Yep.
Ooh, I think we got one.
Believe it or not, what that one more thing on that. Believe it or not, what that is, that's a piece of RG8 with the outer conductor stripped out of it. So you have the inner conductor and the dielectric around it, and it's very flexible, and it'll handle 8 to 10 kV, and it'll hold up well, and it's easy to come up with. So that's a no-brainer.
We have one more picture to have a look at here. Something that okay. What's this?
This is half. I wish I had a better picture off the top of my head, but this is half of the one we just did here in Baton Rouge that I commented on, that the schematic that you showed the first time. This is 2 of the 4 compartments out of that. That's the right-hand compartment here is the ATU compartment for 1460 with the coax clamp in the front. And the left-hand compartment here is the shunt trap only for 1460. And you can see the RF ammeter there. And I took this picture because you see the light up top. Those are LED light strips.
Okay.
And so that was the first time we had done anything other than a conventional light bulb, although we often use LEDs, so they might actually work when you go out to visit it next time. Yeah. But we did the light strips here. We were very pleased at how the lighting worked, but we were somewhat amused to note that if you go out there and work on it, if the stations are running, you get a little bit of a disco there because the LEDs pick up the RF.
We used to do that with fluorescent tubes at high power AM sites.
Oh yeah,
Yeah,
yeah.
hold the fluorescent tube up in the air, and and make the Star Wars lightsaber sounds.
One time in southern Mississippi, I ran the battery out on my fluorescent lantern back when that's all we had, and I was trying to wrap up that day, and I literally took the tube out of the fluorescent lantern and duct taped it to the tower, and it generated enough light for me to see to finish the
Oh
job.
my gosh! Oh my gosh! Wow. Let's we got a couple remaining moments here. Let me ask a couple questions about testing, configuring these things, adjusting them. Before the show, you told me you can substantially set them correctly before you put them on site, but then you got some on-site tuning to do. Tell me about that process.
Well, the traps can be fairly well tuned in the shop because the shape of the box isn't changing. Ground is ground, and resonance is resonance. So you can set pretty much all the traps with a vector network analyzer in the shop, and then you can actually set the ATU part to the predicted impedance. There's a couple of ways to do it, but ATUs don't care which way you look at them. They're passive devices, so they'll transform one way or the other.
Oh.
So if you put a 50 ohm load on the input and then measure the output looking back that way, and you can set it to have the conjugate of the antenna impedance and be reasonably sure that if you hang, the conjugate meaning same magnitude, opposite phase, so it'd be like, instead of 43 plus J15, it'd be 43 minus J15. If you set that there, then if you go hang it out in the field on a load that is 43 plus J15, you'll get 50 J0 on the input. That's one of those things that doesn't seem the way it ought to work, but it does. I guarantee you it does, both
Seems like
mathematically
math
and in the real world.
sorcery to me. Math sorcery.
Yeah, well, the FM. No, sorry, this is AM.
That's right. That's right. So you can substantially set them up when you get in the field and hang it next to the tower and hook everything up. What are some of the things you've got to look for to make sure they're exactly right?
Well, once you get it there, the bottom line obviously is that you want to make a good load for the transmitter, and you want to make sure that there's very little, there's minimal signal feeding back to the other transmitter. And believe it or not, the easiest way to do it, and credit to Mark Mueller for telling me this. Mark's much smarter and more experienced than I am about these things. But you can literally just go back to the transmitter and take the mod monitor out and feed it to your spectrum analyzer or to a field meter. You got to be careful about the level into a field meter. You should always use an attenuator in front of any piece of test gear until you know what your signal source is, so you don't blow up your $7,000 field meter. But once you do that, you can literally go back out to the network and tweak very, very slightly for a minimal signal there, and it's fairly easy. It's like, you don't have to worry about putting a toroid in series or something like that. Here is a sample already there. Just use it. So that works.
Gotcha.
When you have it right, if you pull not the output plug on a primary filter, a series filter, but if you pull the input plug on a series filter and you have it tuned right, the load impedance on the other transmitter should not be affected. You can't pull the output plug because then you've changed the straight capacitance.
Yeah,
But if you pull the input plug, the straight capacitance is all the same, but there's no more current path back toward the source from there. And if it changes there, you're not done. If it doesn't change there, that filter's tuned. Go do something. Go worry about something else. And then once you've done all that, or your turn?
No, go ahead.
Once you've done all that and you're certain that your feedback, crosstalk, whatever you want to call it, to each station is 0 or very, very close to it, then you go out into the field with a field meter and you calculate. There are spreadsheets for it. You can do it. I have a spreadsheet I wrote for it. You got to figure out all the different ways that the two signals can interfere with each other. F1 minus F2, F1 plus F2, 2F1 minus F2, 2F2 minus F1, 3F2 minus the 2, intermount, all the intermount products, right? Out to third order is what the FCC wants to see. So you've got about a dozen different frequencies you've got to measure. And you can do it with a spectrum analyzer, but I do it with a field meter I trust the field meter more to tell me something that I can submit to the FCC directly. The only thing I don't use a field meter for is F1 minus F2, because that's typically way down there in the 100, 200, 300 kilohertz range, and a field meter isn't going to go below 540, obviously.
Right.
But a 41 or a 4100 will go up to 5 megahertz, and that's pretty well. It's very seldom you get a third order that's outside of 5 megahertz. So, and the standards are 43 plus log whatever dB below the carrier. At 5 kilowatts, it's 80 dB below. At 1 kilowatt, it's 73 dB below, and it's a sliding scale from there. But it's never more than 80. Don't AT&T will argue about that with you, but that's another TWiRT. Yeah, another whole program. And then you write it up, submit it, and you're done.
We're talking to Mike Patton, of Mike Patton and Associates, about moving AM stations together to the same property, oftentimes to the same tower or the same towers, and how that's done. And we've been getting a good lesson on that. When we come back after this quick break, we're going to hear a final word from Mike. I want to ask him about ongoing maintenance and what to watch out for if you have a die, tri, or quadplexed AM situation. What do you watch out for? And even if you don't, I think some of the troubleshooting tips would apply to a single station as well. This Week in Radio Tech is brought to you in part by our friends at Vox Pro, available through Broadcasters General Store. We'll be right back.
Hey, what's happening? St. John here, coming to you from Command Central, and wanted to tell you about the absolute best partner you can have in radio. I'm talking about, boom, Wheatstone's Vox Pro. Lots of different audio software out there. Why Vox Pro? It's the only software designed to do what we needed to do, which is record, edit, playback in real time. When I say lightning fast, I'm going to show you how fast you can edit stuff up in Vox Pro right now. So literally 3 clicks on the controller, mark left, mark right, everything that gets marked, you hit delete, it goes away. It's literally that fast. So we're going to take this part right here. Boom. From caller 9 to him saying, I'm ready.
Ready for that secret sound.
Boom. All of that stuff, hit delete, it goes away. Here's your edit.
You are tackling secret sound, caller 9.
I'm ready, St. John.
So one of the best features of version 7, this is awesome. It's effects macros, and you can literally put a chain of effects together so that instead of having to normalize a phone bit and then use noise reduction on it and EQ it and all that, you can literally build a chain. One button, this one's called call right here. I just click that. All of those processes happen instantaneously. Final thing that I love about Vox Pro, and there's so much more to get into, but one of my favorite things, you can load it on a laptop. I've literally done my show from a hotel room in Armenia to the conference room at, this was fun, jury duty. Great thing, no one could tell the difference. Vox Pro makes it totally easy. Telling you, if you're looking for the best on-air partner, call my friends at Wheatstone, ask them about Vox Pro, and you will be glad you did.
And if you want your Vox Pro, you can get it from Broadcasters General Store. What a great partner they are. Terrific people. Call them at, what's the phone number? Do I have this memorized? I think I do. It is 352-622-7700. That's 352-622-7700. They are set up to take your phone calls, talk to you on the phone, give you live, great advice about what they have in stock, how long stuff will take to get to you, what other people are buying, and how it'll work for you. So check that out. Or you can go to bgs.cc, bgs.cc. Check them out. By the way, I want to mention that our show is brought to you in part by a partnership with Radio Guide magazine. Ray Topp publishes a terrific magazine 6 times a year. Every 2 months you get a new radio guide, and the articles are in depth. They have plenty of good authors, good articles, things that you need to be concerned about or know about in your role as a broadcast engineer. Radio Guide on the web at radio-guide.com, radio-guide.com, or you can apply for your own mailed copy and read it, peruse it at your convenience. All right, we're going to wrap it up here with Mike Patton. Mike, we've been on the air for, so to speak, for a little over an hour, and I want you to wrap it up with a little bit of word about troubleshooting. What can go wrong, and how would you know?
Well, this is fairly straightforward. If something fails, you'll know about it. The first thing that will happen almost always is that the reflected power will go to hell on one transmitter or the other, or both. Mm-hmm. And then you got to hope that when you go out there, there's going to be something visible. Because if it's not visibly failed, top blown off or cracked open or something like that. Then you have to break out the test gear, and that generally means you have to bring in someone with the test gear and the skills that someone on my level has. But the good news is that most of the time when something fails, it's fairly obvious. There's a squirrel across the ball gap, or
Yeah.
the vacuum capacitor has decided to let its vacuum out, or one of the big black mica caps has decided to ooze its goop everywhere. And then as long as it's a fixed vacuum or a fixed mica, you're good. You just take the old one out, put the new one in. If it's a vacuum variable that's failed, it's probably not going to be able to for you to measure the value it had. So you're going to have to retune it, and that goes back to getting somebody in there with the test gear and the skills to either do it or to walk you through it. So
Gotcha.
it's it's definitely more complicated than not. It's every now and then you'll find a situation where the reflected powers still look good, but you've busted the limit on an intermod product. I've never seen that yet. Theoretically, it's possible. And the other thing is that if it were to happen, who's going to be affected? No harm, no foul, unless that intermod product happens to fall on somebody else's frequency that's bothered. You'd never know it.
Yeah.
So there's two stations in New Orleans that are not diplex, but they're close enough to each other. One of them is a well-known 50 kilowatt that they had to have traps for each other. And when one of the traps died at the lower power station, it was a 2-tower DA, there was an even lower powered station that was across the like Pontchartrain in Mandeville at Covington, and they would be wiped out by the Intermod product in downtown New Orleans. So they were on the case immediately if one of the traps failed, and one of the traps had a tendency to fail every now and then in a way that didn't really bother the station it was in, but it would absolutely pop that spur up, and those folks in Covington would be on the phone 5 minutes later.
All right. Well, a lot of higher power circuits and systems, problems are often self-evident. You can see the damage that was done. So, there it is, right there. Not always, but I've been lucky.
Yeah, what happened here, this was a special case coil. You can still get them. Kidtronics and others will make them for you. It's a double wound coil. It's a big coil, and then there's like an outer winding around the inner, and you take the outer side and you resonate it with a cap, and this makes a parallel resonant circuit that makes the original coil act as though it also is a parallel resonant circuit. And I've seen several of those. In fact, I've got one of those coils in my inventory right now. And what happened is that lightning would hit the tower, and the magnetic field would suck that coil in like an accordion, and it would no longer resonate.
Yeah.
Oh yeah.
Yeah. It would actually suck up the coil. The metal would go whoop like this.
Yep.
Like it's like a collapsed slinky.
Yeah, that's right, like a collapsed slinky. Or Paul Bunyan stepped on it.
Yeah. Mike, I wish we had more time to go, but we are out of time. It's been a real pleasure to talk to you about moving in together, AM stations. And for some, it just might make sense. Keep you on the air for a few more years or decades or something, and sell that property, make your millions, and either retire or put it into your moved AM station.
There you go. Well, thank you for having me, and I look forward to being your guest again. You take care.
Don't hang up. We're going to grab a picture right after. Thanks a lot to our sponsors on This Week in Radio Tech. Be sure you check out bionic.radio for the Camera One system and the other systems that they have. Cool stuff. Vox Pro, you can get that at Broadcaster's General Store. Also, Max Connect Wireless, and our friends at Angry Audio, where they have all kinds of stuff that you need. Check it all out and look for our website. Subscribe to our YouTube channel if you would. It's part of the GFQ network, but just look for This Week in Radio Tech or TWiRT on YouTube and look for the current logo and subscribe to that. We'd very much appreciate that. Tell your friends about This Week in Radio Tech, and importantly, come in next time. Next time, we're going to have a talk about some newfangled transmitter stuff from always new technology from our friends at Nautel. And then next month, we've got an update from Mark Johnson of Link Up Communications. That's coming up next month about this whole C-band repack stuff and what you need to do in terms of filters. And did you sign up for a lump sum payment? How are you going to get your money out of the government? That's an interesting challenge right there. I want to thank Suncast for being the producer on This Week in Radio Tech. Thank you for the great work. I appreciate that. And Andrew Zarian, the founder of the GFQ Network, home of other fine podcasts. We'll see you next week on This Week in Radio Tech. Bye-bye.